Okay, this is going to be problem number 8 of our problems. What we're going to be able to see here is 3x minus 2y is equal to 6. And now 3x. Oh, come on. Let me just redo that. It's going to be 3x minus 2y is equal to 6. And then we have x is equal to 4. Okay, top one is definitely standard form, and we want to be able to convert it. One of the things that I've always told you guys, or I showed you guys, is we can use the equations negative a over b for your slope, and our intercept will be y is equal to, or y-intercept will be equal to c over b. We want to be able to identify and label these, so I know looking in standard form, this is a, this is b, this is c. If I'm going to find my slope for the top one, it's going to be negative a, which happens to be 3, my b, which happens to be negative 2. Okay, I know probably some of you guys got this mixed up because you guys forgot that negative and negatives cancel out. You kept one of them negative. That might have been the case. It's not that you're dumb or you forgot. Even sometimes when I do these problems, I make mistakes like that, and I have a degree in math. So just write out the one step, and it will help you out further. That's probably the biggest thing. So we have our first one, 3/2. Our y-intercept is c over b. So we're going to do 6. Our b is negative 2, which gives me negative 3. Again, write it out. Probably got that one mixed up for some of you guys. Okay. If I want to graph this now, I now have my slope intercept types. So I'm going to go down 3, up 3 over 2. Up 3 over 2 is going to give me this line. That deals with my first graph. The next one here, we have x equal to 4. Is it standard or slope intercept? No. So we know it has to be a Hoy or a Bucks. In this case, because we have an x, it is a Bucks. So we know it's a vertical line that goes up and down at our x value. So I'm going to go to 4. I'm going to go up and down at that point. Nice part about this one, it gives me one solution. My solution happens to be 4, 3. Good stuff? Good. I'm going to clear it. I'm going to do number 12 now. I'm going to request for number 12. We're going to go ahead and do x minus 3y is equal to negative 3. 2x minus y is equal to 4. Same kind of process happens with this. We have our slope being negative a over b, and my y-intercept being c over b. So I want to be able to find that out with both equations. Now, if there's nothing in front of the variable term, what can we always put in front? 1. Always, always, always. Sometimes it helps just to put those in there so we can identify them. I'm going to label this A, B, and C for both terms. And let's go ahead and find them. Let's go ahead and find them. For the top one, my slope is going to be negative A. So negative 1 over B, which happens to be negative 3. Again, it's that negative and negative that probably got you. Probably that got you, right? Maybe? No? Let's keep on going. Let's see what happens. Okay. We have the negative 3. We're going to look at the y-intercept, which was c over b. It's going to be negative 3 over negative 3. Again, it might trick you up. Negative 3 over negative 3, 1. Okay, so we have that first one. We'll do the one down below as well. We have our negative a, which happens to be negative 2 over b, negative 1. This is just going to give me 2 over 1. Or you can write 2, as long as you understand that we have to do rise over run. Y-intercept is going to be doing the same thing, in which we're going to do 4 over negative 1 or negative 4. So we have those two. Let's go ahead and graph them. I'm going to go up 1. From that point, I'm going to go up 1 over 3. So it's going to give you these lines here, crossing somewhere like that. And our bottom one will be down 4 for our y-intercept. Doing this one first, this second, and then we're going to do 2, 1 over 2, up 1, up 2, over 1. And we get a nice intersection point at the value of 3, 2. Good. What did we do wrong? What was it wrong? What was the wrong part?
Actually, I got it right.
Did you? Okay. Okay. Hey, it's all right. Cool. Good. Rechecking it. Okay. Good.
On the paper, it
It
says
said,
-2.
that's why I changed.
-2?
-2.
Yeah.
Oh, my bad. Thank you. If you think you did it right, let me know. If you did it right, let me know. I make boo-boos sometimes. You know. Okay. Yeah, 3, 2. That's a correct one. That's a correct one. Okay, that's a correct one. Okay. Here you go. Oh, yeah. Go for it, Chad. Hey, good to see you. Okay. Here we go. Take out that paper. I'll try to do more. Appreciate it. How's your class so far this year? Good. Good. Good so far. Good so far. I have Val for pre-calc, so it's kind of.
She's lucky.
Are you taking pre-calc? No. Are you down?
Stats.
Scranton? Lane. He's good. He's good. He'll enjoy it. I mean, it's 2 different worlds. 2 different worlds. So. All right, ladies. Have a good one.
Bye.
Okay, here we go. We have our things that we want to kind of write down for this. So here we go. We're going to kind of jump at this. Systems of linear equations is basically two linear equations that share a solution. Just to try to put it in context of what we've been doing. A solution of a linear system is a point where they both intersect. Is a point in which they both intersect. Point of intersection is the same thing as a solution to the system. We kind of talked about that. We did this in the last couple of problems. Our last one was 3, 2, so we know we have that. Okay. No solutions, which we're going to talk about today, means that the lines never intersect. And our last one that we're going to talk about as well, a system can actually have infinitely many when the lines are identical. I hope I spelled that right. If not, don't hold me to it. I'm not a good speller at all. I have trouble spelling my name. Okay. Good? Okay. So we're going to look at these. We're going to look at the different types. We're going to come back and look at some graphing, and then we're done. We're done. You guys are good to go. What time we get out today? At 12? 11:48. Okay. 28 more minutes. We can do it. Do it. Okay, here we go. Now, with the problems that you see down below, we're going to kind of fill these things in. There's several things that I want you guys to highlight and identify. This is what I'm going to ask you guys on Friday's quiz. I'm going to give you some equations. I'm going to ask you for these. The biggest thing that we're going to see here is you see 3 different types of ways that lines can cross. Our first case in which they cross at one point, the second one in which they'll never cross, and the last one is going to give you the same line. Right? What happens when it gives you the same line? So looking at our first one here, the first thing we want to be able to identify is that they're different slopes. Different slopes automatically means we have one solution, period. Doesn't matter if the y-intercept is any different or the same. If it has different slopes, we have one solution. So the lines intersect. That means we only have one solution. Intersect. I spelled that super wrong. Hold on. Sex. S-E. Leave me alone. Enter C2. Thank you. Sorry. Thinking I'm already ahead. Okay, next one. If we're given the second part of this and we see that they identify the same slope, so we're going to look at the slope first, and we come to find out that there is a different y-intercept. That means we're going to be given two separate lines that are next to each other that are considered parallel. The lines are parallel. So there is no solution. No matter what value you plug in, no matter how you solve it, no matter what way you graph it, if the lines do not cross, they do not have a solution. And our last one, if we identify that they have the same slope, and then we go on that further and we find that they have the same intercept, that means it's the same line. That means no matter what value you plug in, we're going to be given the same solution. So if the lines are identical, so there are infinite. I'm going to put many. I'm going to put infinite, all, however you want to explain to me what it means. Infinitely many means no matter what value you plug in, it'll be the same. So we want to be able to look at these and identify the different types. Okay, identifying the different types is going to be crucial. Looking at our next one. So we're going to practice what we're going to identify with, and then we're going to kind of do a couple problems, and then we're done. Then you guys are free to do your thing. There you go. So those are the three different types we're going to do. And you guys have the graph, you guys just don't have the equation. Oh, no, that's not it. Sorry. Hold on. Going back one. Going back. Here you go. There you go. I'm going to go ahead and erase this last one here. I know you guys have it. You don't need to do this, but I just want to show you. Okay. It almost comes down to finding different things. So the first thing we're going to do, and I'm going to erase this after this one, but the first thing we want to do is find slope. If you want to put this on the sign somewhere, you can do that. Find slope. I'm going to put it in two different categories. If it is different, or same category. Okay. If they are different, that means we have our final thing, and we're going to have one solution. One intersection, one value. If you're going to do the same one, that means you have to do an extra piece of criteria. The next step would be to find the y-intercept. Find y-intercept. And again, we're going to branch this one off to where we're going to do here and here, where if it's going to be different, we're going to have no solution. And if it's the same, we're going to have many. Does the tree make sense? Yeah, hopefully. Okay, so that's the criteria. This is the process in which we want to do these. We're still going to graph them. But we're going to identify the slope first. We want to see how many solutions we have. So I'm going to do my first one here. Starting out with, I want to be able to find the slope. So my slope for the first one, our slope for the top one, how about that? Our slope for the bottom? Are they the same or different? Different. So because these are different, we know that they are what? How many solutions do we have? One. Done. Now, if I'm just asking you if I ask you how many solutions this have, you should be able to just tell me one. Without solving it, tell me one. I'm going to have questions on that. Don't solve it. Tell me how many solutions we have. That's what I'm going to ask you guys on Friday. I'll give you like 4 of them. Tell me. All right. Find the slope, tell me. Okay. Now I can give you the extension. I can go graph it and tell me the solution to the set. So that's exactly what we're going to do. We're going to continue on. The y-intercept for the top one is going to be what? 2. Good. The bottom? 1. Perfect. If you haven't done so, graph them. Graph the top one. I'm going to go up 2 for my y-intercept, up 1 over 1 for a slope of 1, because 1 can be converted to 1 over 1. So that's my first line. Second one here on the bottom. We started from the bottom. Now we're here. Started from the bottom. Now we're here. Okay, here we go. I'm going to do my slope now. I'm going to go up 2 over 1. Look at that. It's actually on our point. How nice. What's my solution?
1, 3.
1, 3. So this one works out perfectly. Que bueno. Que bueno. Okay. Second one, let's figure this out. So we're going to go on another adventure to solving, finding no solution. I know it tells you no solution. I want to show you guys why it's that way. Okay. Now the second one, we got to be able to do the same thing. So we're going to look at and find our slope. So we're going to look at this. We're going to find our slopes. So m is equal to 3. M is equal to 3. Same or different? Same. So that means we're going to follow down this pathway now, right? So I got to be able to do my second step now. I got to be able to find the y-intercepts. My y-intercept on the top is 2. We're going to put y-intercept is 2. And the bottom one is -2. Are they the same or different? So this was diff. And this is also diff. So different and different. So they're the same. I'm sorry, they're the same. Oh, making boo-boos today. This is same and different. So same on one side, different is going to tell me how many solutions do I have? None. 0. Nada. No solutions. So it's going to be none. If I graph this one, and I'm going to graph these ones at a quicker rate, I'm going to go up 2, up 3 over 1, back 3, back 1. That's my first one here. It's hard to draw on glass. Then I'm going to go do the second one. I'm going to go down 2, up 3 over 1. Come on, baby. Come on, baby. And of course, they don't intersect. They don't intersect. So we're good with that. I'm hoping to get all this. Haha, I did it. Can we move this a little bit over? Sorry. Oh, I didn't do it. Let me try this again. Oh, dear. Oh, that was super wide. No. Move this one over. Hopefully that'll be a better spot. There it is. Sorry, it's on the next page. Yeah. It's not going to work out. I'm just going to erase it. Gotta work on that. And our last case that we see here, so you guys should have that on your guys' paper. If you guys don't, it's okay. Next one, we're going to look at our slopes. Pretty much, let's just identify them. What do we have here? Same slope. So our slopes are the same. M is equal to -3/4. And what's my y-intercept? So same and same tells me it's going to be how many solutions? Many. So many solutions is going to be good. And we're going to go up 3, down 3/4. It's going to be the same line. So I know mine's a little bit off. Leave me alone. Oh. Try my best. Try my best. And that's all we're doing. That's all we're doing. Easy or hard? Easy. I'm going to give you guys your homework. I'm not done yet. I'll do the first couple problems for you guys to tell you what I'm looking for. And you guys are free to do it. Okay? Very well. Very welcome. Yes. I'll be that guy. Okay, I'm going to do the first two with you guys. If you guys want to jump ahead and go for it. You guys have got plenty of time in this class. So we got, what, like 10 minutes? Here we go. Number 1 and 2, I'll do them for you. If you want to just wait for me, if you want to jump ahead and skip over and do the next one, you're more than welcome to do that. We're going to look at more solid problems tomorrow, draftsman as well. So we need to get the substitution as well. It's going to be fun. Some good stuff, man. Good stuff. Okay, first thing I want to be able to do here is we're going to look at the one, many, or none. We got to be able to identify the slope and intercepts. So I'm going to do slopes. My top slope is 3/2. This is definitely y equals mx plus b. The back one is going to be -2, which is going to happen to be my y-intercept. My slope for the bottom one is going to be 1/2. My y-intercept is going to be 2. Just by looking at my slopes, are they the same or different? Different. So if they're different in the beginning, what do we know about it? How many? One solution. So I already know I'm going to have one solution if they're different slopes. Right? So here we go. We want to graph it and find out the solution to the set. I'm going to graph the top one in orange, and I'll do the bottom one in, give me another color. Green. Heard it. Heard it. We'll do it in green. Mr. Green. Okay, I'm going to do the top one. I'm going to do my y-intercept first. So I'm going to go down 2. right here. And then I'm going to do my slope. So from my point, I'm going to go up 3 over 2. Up 3 over 2. Boom. First one done. Bottom one will be our other one, where I'm going to do my intercept first. I'm going to go up 2, and then I'm going to go up 1 over 2. I did a boo-boo on this last class. So I went down. You guys are good. You guys are good. What is my solution? Anyone? Anyone? I heard it. Someone said it. Fo. Beautiful. Done. Dunzos. Cool beans? Let's look at the next one. We want to identify the slope first. Slope and intercept. So slope. If there's no variable or there's no value in front of the x, what can we always assume it to be? What is it? 1. So I'm going to put 1s in front of those so you guys can see them. My slope is going to be 1 over 1. Y-intercept will be 2. My other one is going to be a slope of 1. Y-intercept would be -3. Now, again, we want to identify how many solutions we have in this. So the first thing we did is we looked at slope. Is it the same or different? Same. So we had to solve, we had to look at it a little step further. We had to either say, is it the same or different y-intercept? Different. So if it's different, how many solutions? None. So I know we're going to have no solutions with this one. So if they cross, I know I'm messing up somewhere. So if we're going to graph the top one, we go up 2, up 1 over 1. Try to graph this as accurately as I possibly can. There you go. Next one down below, we're just going to go down 3, up 1 over 1. And it makes sense. No solutions. It is a null solution. There is no, probably not a null solution, but a non-existent solution. Questions? You guys good? Yes, go for it. Number 4. Let's look at it. Okay. What's your question?
The second one, I don't know how to break.
What's your equation? X plus 1. Can it be graphed? Does it go off it pretty bad? Oh, just by what, 2? 1? It's okay. If it's by 1, it's fine. It's fine. Because you went up 1 and then went down before you go over. Yeah. Go down 7 and over 3. Right? Is that what you guys did? It just goes out the paper by 1, huh? Because you got to do 6. Yeah, you can interpret what it's going to be. Yeah, I'm not going to be too crazy on that. Anything that I'm going to give you is going to give you a good, like, graphable graph. Does that make sense? So what you guys probably did for this one, I kind of erased the other one, but you guys went up. So it's something like this. And then what I would have done is you can probably go up 7, back 3, but it's not going to really help you because then you're going to be more off the paper. So you did 6 right here, right? And then you went over 1, 2, 3. Is that where you guys kind of put your thing? Right. That's fine. I did that right. Yeah, I did that right. Yeah, that one's fine. I should have just changed it to a nicer. Questions at all, guys? Okay, go ahead and get started. Go ahead and get started. Some of you guys are already done.